Okay, good morning. This is a question I want you to know how to solve it. Now, this is the second derivative. The first one that I taught you was the first derivative. Now, looking at the question, you can see we have if s squared plus y squared is equal to 25, find the squared y over the s squared at p, 4, 3. That's the point. Now, let's get to the solution. So take the differential or take the derivative of s squared plus y squared is equal to 25. You will see 2x plus 2y dy dx. Note this, anytime when you're differentiating a y function, introduce dy dx is equal to 0. Okay. Then we make dy dx the subject. And finally, we are going to get negative x on y. Now, the question demands the second derivative. So, to find the second derivative, this is how you go by it. Take the derivative of dy dx. So, d dx of dy dx is equal to negative x on y. So, you can get d squared y over dx squared is equal to d dx of the equation or the expression minus x on y. Now, watch this. When you reach this place, you have to use the quotient rule. That's differential d dx of u on v. Now my u is negative x and my v is y. So this is the formula for the quotient rule. If you've forgotten, you should remember. V du dx minus u dv dx all over v squared. Now watch this. Here you can see that u is equal to negative x and my v is equal to y. So du dx is equal to negative 1. Now dv dx is equal to dy over dx. Now watch what we have here. So inputting everything or substituting them into the formula, you get y being the v. Then you have du dx as negative 1 minus, now introduce the bracket, into bracket negative x dy dx. And initially we were able to find dy dx as negative x on y. So you make the substitution into where you see dy dx. And after simplifying it, you are going to get minus y squared minus s squared all over y cubed. So at the point P43, you are going to see this. So d squared y over dx squared is equal to negative 3 squared minus 4 squared all over 3 cubed, and you get negative 25 on 27.